Hello, today we're going to present about line balancing. Let's do it.
Hi, Assalamualaikum and selamat sejahtera. So today I will explain about designing product layout. The objective of designing product layout is to balance the assembly line. Besides that, I will also explain about line balancing, procedure requirement and also cycle time. So, first we must know what is the product layout. The product layout is a design that position workstation are together based on the product they make. Machine are laid out sequentially so product can transfer from one station to the other station in order until they are finished. Product layout arrange resources in sequence so that the product can be made as efficiently as possible. Usually, this type of product layout is used in repetitive processing system that have high volume of one standardized product. There are differences between product layout and process layout. In product layout, the material moves continuously and uniformly through a sequence of operation until the work is completed. So, how to avoid bottleneck in product layout? Bottleneck is a point of congestion in production system that occur when workload arrive too quickly for the production process to handle. The inefficiency brought about by bottleneck often create a delay and higher production rate. So how to avoid bottleneck in product layout? First, we can assure that the bottleneck works only a quality part. Second, we can add resources at the bottleneck operation. Next, I will explain about assembly line balancing. What is line balancing? Line balancing can be defined as assigning proper number of worker or machine for each operation of an assembly line so as to meet required production rate with a minimum or zero idle time. The importance of line balancing is to improve process efficiency, to increase production rate, to reduce total processing time, and also potential increase in profit and decrease in cost. The primary benefit of assembly line is that they allow worker and machine to specialize at performing specific tasks, which can increase productivity. Large-scale assembly line can allow for mass production of goods that would not be possible if products were made from start to finish by a single worker. So the next slide is I want to show what is the effect if the line balancing is unbalanced and balanced. If the line balancing is unbalanced, high workload in some stage will overburden. So besides that, it will also maximize waste in overprocessing, inventory, waiting reward and transportation and motion. It also will make high variation in output and poor efficiency. So if the line balancing is balanced, it will minimize idle time, will increase the efficiency, will promote one-piece flow, and will avoid excessive workload in some stage and reduce variation. So there are 6-step assembly line balancing. First is to select tasks, estimate time and draw procedure diagram. Second, specify the daily output level and calculate cycle time. Third, calculate the minimum number of work center. Fourth, develop an initial file. And 5, evaluate the current layout. And step 6, if possible, improve the layout. Assembly line balancing operate under two constraints, which are procedure requirement and cycle time restriction. Actually, procedure requirement we already learned in operation management before. So I will explain short detail what is the meaning by procedure requirement. The procedure requirement are physical restriction on the order which in operation are performed on the assembly line. For example, we would not ask a worker to package a product before all the components were attached, even if he or she had the time to do so, before passing the product to the next worker on the line. To facilitate line balancing, procedure requirements are often expressed in the form of precedent diagram that I will show to you later. The precedent diagram is a network with work element represented by circle or nodes, and precedent relationship represented by a directed line, segment and connecting the nodes. So, here a precedent diagram method, or we call PDM, a diagram that describes the order in which work elements should be performed. It shows that some job cannot be performed unless their precedents are completed. The layout of workstation along the assembly line depend on the precedent diagram. So as you can see, there are boxes in the precedent diagram. The precedent diagram method is a tool for scheduling activity in a project plan. It is a method of constructing a project schedule network diagram that use box or referred as node to represent activity and connect them with arrow that show the dependency. There are 4 type dependency, which are start to start, finish to start, finish to finish, and start to finish. Next, so the most significant advantage of using precedent diagramming method is that it quickly allow the project team to understand all the schedule activity and its affiliates with each other.
Right now, I want to share with you all about cycle time. So, right now, I want to tell you all about how to calculate the cycle time. So, before we learn how to calculate the cycle time, we must know what the definition for cycle time. So, for me, the cycle time is about average time between completion of unit. And cycle time also include process time and delay times. That means during which a unit of work is spent waiting to take the next action. So, the formula for cycle time is production time available divided by desired unit of output. I give one example. For example, production company A have 8 hours and 60 minutes, and company A also have unit of output of company A have 120 units. So, recording about the formula cycle time, production time available is 8 multiply 60 minutes and divide by 120 unit. So we can get 4 minutes for production company A. So next, about line efficiency. So what the meaning of line efficiency? Line efficiency is about ratio. It's about ratio. That means number of hours during which a high volume peak and place missing actually. So, for example, efficiency line have formula. The formula is output divide by input multiply 100. So, this formula is so easy for we to understand about line efficiency. This is a basic formula because line efficiency is the basic formula ratio of output to input expressed by as a percentage. So I repeat, line efficiency, the formula is output divide by input multiply 100. So
Okay, now we discuss about line balancing procedure. The first step you need to do is draw and label a precedent diagram. This is a flow chart where the circle represents the task and the connecting arrow represents the resident, like this figure. Step 2 is calculate the desired cycle time requirement for the line. What is formula for the cycle time? So the formula for the cycle time is available work time divided by the desired output rate. We need to find the available work time. So available work time is scheduled work time minus the break. The third step is calculate theoretical minimum number of workstation. The formula of theoretical minimum number of workstation is sum total of tasks divided by the cycle time. Step 4 is group element into the workstation, recognize cycle time and precedent constraint. Step 5 is calculate efficiency of the line. Step 6, the last step is determine if the theoretical number of workstation or an acceptable efficiency level has been reached. If not, so you must go back to the step 4. That's all.
Hello everyone, today I will talk about what is line balancing and how to calculate. It's more for calculation, so saya akan cakap more kepada calculation macam mana nak kira line balancing. Okay, so first kita kena draw the precedent diagram. Yang kedua kita akan calculate cycle time. Yang ketiga kita akan cari the number of workstation. Yang keempat kita kena make line balancing. Yang kelima kita kena determine the efficiency. Okay, next. Okay, first kita kena draw the precedent diagram. Okay, contoh dia dah bagi diagram kat kita. So dekat sini kita ada 4 elemen, iaitu A, B, C dan D. So yang pertama buat elemen dia, dan dekat sini dia bagi kat kita precedent. Okay, saya nak campaign dah. Sini dia bagi kan. So dekat sini dia dah bagi dekat kita. So ini kita kat sini dia bagi time. So sini dah complete lah kita nak buat precedent dia. Dekat sini kita kena create satu precedent diagram untuk nak tahu arah flow. Okay, first A akan bermula, titik A akan bermula. So dia dekat sini dia paling ni dia akan start lah kat sini kita. Dia akan mula kat sini. Dia akan mula, A akan bermula kat sini. So A bermula yang kedua pergi ke B. So B pergi ke B. So C pula bermula daripada A. So C bawa ni. So B, C. Okay, B bermula daripada BC. So letak arrow kat sini, BC. So jangan lupa lepas kita dah buat ni, kita kena tulis time dia kat sini. So kat sini 0.1, 2.0, 0.4 dan 0.3. So kita dah create precedent diagram. So this dia punya formula. So formula dia adalah production time variable kita bahagi dengan desired unit of output. So dekat sini kita dah ada information. So dekat sini 40 jam kita darat dengan 60 minit, kita bahagi dengan 6000. Kita akan dapat 2400 bahagi dengan 6000 sama dengan 0.4 minit. Okay, so kita akan dapat cycle time kita 0.4 minit. So langkah ketiga adalah determine the number of station. So dekat sini formula untuk minimum number of workstation ialah sum of process time, iaitu process time yang kita tadi elemen time tu, bahagi dengan cycle time. So kita dapat dekat sini kita punya previous data dia dekat sini 0.1 tambah dengan 0.2 tambah 0.4 tambah 0.3 bagi dengan 0.4, kita akan dapat dekat sini 2.5. Tapi untuk station dia tak boleh ada dalam perpuluhan. So kita convert dia, bawa kat sini akan dapat 3 station. So ada 1, 2, 3 station. So ni nanti kita akan susun dekat line balancing. Okay, step kita akan buat map line balancing. So dalam map line balancing ni kita kena buat diagram juga macam ni yang baru. So sebab kita ada 3 station, so kita kena buat 1, 2 dan 3. So dalam elemen A dengan B, dalam elemen workstation 1 ada 2 elemen yang dimasukkan, iaitu A dengan B. Kerana A dengan B mempunyai 2 remain elemen kat sini, remain elemen. So dia ada elemen kat sini, contoh maksudnya A mempunyai C punya elemen dan B mempunyai C juga dia punya elemen. So kat sini kita letakkan A dan B dalam satu station. So A kita letak dekat sini A kita letak dekat sini 0.3, iaitu dan kita tahu C 0.4. So kat sini akan dapat 0.3. So B kita akan dapat 0.1 kat sini. Okey, 2 C 0.4. Seperti mana yang kita tahu, C adalah 0.4. So maaf, ini terbalik. Okay, ini sepatutnya 0.4. 0.4, maaf, 0.4. Ini sepatutnya 0.4 dan ini 0.3. 0.3. Okay, ini 0.3. So kat sini 0.4 tolak 0.4 akan dapat 0. So dia punya remain ni adalah D. Dia akan pergi ke D saja, berhubung ke D. Dan workstation yang ketiga adalah 0.1. Sebab apa? 0.4 tolak dengan 0.1 akan dapat 0.1. 0.4 tolak dengan 0.3 dapat 0.1. So dia punya elemen tak ada sebab dia tak pergi ke mana-mana. So dia akan stay. So yang inilah yang dia punya workstation yang baru. So A, B workstation 1, C workstation 2, D dan D workstation 3. So next kita nak nak tahu. Kita nak, last kali step kita nak tahu the efficiency untuk line balancing. So kita dah kat sini, lepas kita dah buat kita dah buat diagram tadi, kita buat ikut arrow macam ni. Kita buat arrow macam ni. Okey, kita buat arrow, maksudnya buat session pertama A, B. Buat session kedua C. Dan buat session ketiga adalah D. So kat sini, kita dah buat macam ni. So kita akan calculate the efficiency. So formula dia adalah process time kita bagi dengan lead time dengan 100. So process time ni mana kita nak dapat? Yang tadi juga, daripada tadi juga, 0.1 sum of process time 0.1 tambah 0.2 tambah 0.3 tambah 0.4. Kita bagi dengan lead time. So kita punya workstation adalah 3. So kita punya cycle time 0.4. So kita akan dapat ni. So darab dengan 100. Darab dengan 100. Lepas tu kita akan dapat 83%. So itu saja. So semakin tinggi efficiency.
So here is the tutorial 1 of the line balancing. This is the question. Best vision is revamping its assembly lines to improve efficiency. As shown below, there are 10 steps to assembly a television set. A. If Best needs to produce 120 televisions in a 40-hour work week, how should the line be balanced? Given that one worker is assigned to each workstation, how many workers are required to operate the line? What is the efficiency of the line? B. If demand for televisions is reduced to 100 sets per 40-hour week, how many workers will be needed to man the line, rebalance the line, and recalculate the efficiency? So here the task and precedence and the time. So let's summarize the question first. For the requirement A, working hours 40 hours, number of production 120 units. For the requirement B, working hours 40 hours and number of production 100 units. After we read the question, we need to draw and label a precedent diagram. At the table there we see task A, precedent is none. That means we need to start from A and put it at the left side. After that we see B, C and D, precedent is A. So we need to put the arrow from A to B, A to C and A to D. After that we see the task E, the precedent is B, then put the arrow from B to E. And the task F, precedent is C and E, then put the arrow from C to F and E to F. Then we can see the task G is D, the precedence, so need to put the arrow from D to G, and H is G, then put the arrow from G to H, and the I is F and H, so need to put the arrow from F and H to I. And the last one is task J, precedent is I, then put the arrow from I to J. After that we do label the time at the top or below of the diagram there. Okay, next, we need to calculate the desired cycle time required for the line. The formula of the desired cycle time is production per day divided by number of production. And the desired cycle time is 40 hours times 60 minutes divided by 120 units. Then we can get 20 minutes for the cycle time. After that, we need to calculate the theoretical minimum number of workstations. And the formula is total of time divided by cycle time. We need to total up the time 8 plus 4 plus 7 plus 3 plus 7 plus 11 plus 2 plus 5 plus 8 plus 7, then divided by 20 minutes. Then we can get 3.104 workstations. Next, we need to group the elements into workstations, recognizing cycle time and precedence constraints. First thing first, we need to note the cycle time is 20 minutes. So we need to group the elements to workstations. However, there are multiple ways to group the elements into workstations. For me, I place the A, B, C in the workstation, and the time is 19. And the next one, D and E, and the time is 10 minutes. And F, G, H in the workstation, and there is 20 minutes. And the last one, I, J in the workstation, there's 12 minutes. So total out there are 4 workstations and 4 workers are needed. And after that, we need to calculate the efficiency of the line. And the formula is total time divided by number of workstations times cycle time. So there is 62 divided by 4 workstation times 20 minutes, and there is 0.775 or 77.5%. And for the B1, we also need to draw and label a precedence diagram, but actually they are same, just do like the A1. Okay, now we need to calculate the desired cycle time required for the line. The number of production is different because the A1 is 120 and the B1, this one is 100 units. So the formula is the same, just the number change. So there is 40 hours times 60 minutes divided by 100 units. Then we can get the new cycle time 24 minutes. After that, we need to calculate the theoretical minimum number of workstations. Same, we need to total up the time, then divided by the new cycle time. So this we can get a 2.58 or 3 workstations.
So for 4, okay, after we get the cycle time and precedent constraint, so we figure at the workstation. For first workstation is ABCD, second workstation we go to EFG, and third station is HIJ. So there are multiple ways to group the element into the workstation, and 3 workers are needed. So 5. Next, we calculate the efficiency of the line. So the formula is total time divided by number of workstation or cycle time. So we get 62. So we get 62 over 3 times 24. So we get 86.11%. So that is the efficiency of line. Thank you for watching our video.